So today's lesson is on representing and identifying nonlinear relations. So all of the scatter plots that we've seen so far have demonstrated either um, no correlation or positive or negative correlations. Today we're going to be examining nonlinear relations. So it's possible for there to be a trend, but that trend is not a linear trend, as we've been seeing. So what is a nonlinear trend? Well, a nonlinear trend is there's still a relationship there, but the graph does not form a straight line. So if the graph does not form a straight line, it's not appropriate to draw on a line of best fit, right? Because remember that line of best fit is there to demonstrate, on average, the linear relationship that's there. Right? However, having said that, instead, sometimes it makes sense to draw a curve of best fit. And so today, what I'm going to do is showing you an example of what it might look like if you have a nonlinear relation, but there's still a relationship that's evident. So you may remember on Google Sheets when we were creating scatter plots, using Google Sheets as a form of technology, you'll remember that I discussed the fact that you can insert a line of best fit under the Trendline section. And we tried out a few different types of trend lines, and we found that the linear one gave us that line of best fit. Now, what you'll see in our next example is an example where the linear trend line just does not make sense. And so we'll fool around a little bit with the exponential and polynomial trend lines and see if they fit. So let's go on to the example. So I find it super helpful when I look at a graph where I see that there is some kind of a trend to try and interpret not only that there is a trend, but what the meaning of that trend is. So in this particular graph, I can see that there's a bunch of different people that were, I guess, polled and who experienced depression. And we looked to see, well, how many hours of sleep were they getting per night? And based on the trend, I can see that it's not a linear trend. There's sort of a curved trend here. I can see that, the rate of depression is high if you get 4 hours of sleep, and gets better and better. Your level of depression decreases as you get more hours of sleep up to a point. So it looks like, about 8 hours of sleep a night, your level of depression kind of gets to be the lowest. But then what happens is that if you are spending a lot more time in bed, right? So 10, 12, 14 hours, then your level of depression goes up. Maybe that's an indicator of the fact that you are depressed, the fact that you're spending more time in bed. So I would assume that these are adults that they polled, mainly because teenagers tend to need more than 8 hours of sleep. Teenagers with their growing brains tend to need more like 10 to 12 hours of sleep. But still, nonetheless, it shows you that there's a point where the amount of sleep you get is perfect, but then outside of that range, the amount of depression seems to increase. So here's another example of a nonlinear trend. This graph is showing population versus year, right? So I'm assuming it's the population of people in a certain area or country or something like that. Well, it looks like it must be maybe a city based on the numbers that are here. So let me give you an example. This is specifically an exponential relationship, but you don't need to know it. You just need to know that it's nonlinear. So it wouldn't have been appropriate to draw a line of best fit here because I can see that it's definitely a curved trend. And you can think of it as it's not linear because let's say let's imagine that this is like with bunnies, for example. I would start out with like one little bunny, and then the bunny would have babies, right? Maybe we're going to assume just 2 babies, but it could be more. And then so new little bunnies, and they're going to mate and have, more bunnies. And so then, as we go on, we're doubling the number of individuals in that bunny population, right? So, it's going to go up by more every time. Right, we started with 1, then 2, then 4. If we went on here, it would be up to 8. and then 16, and so on and so forth. So it would be going up by more every time. So here's another relationship. This one is actually from your workbook, and I really liked it. It's an example of a decreasing trend, right? So it's not a linear decreasing trend, but there's definitely a correlation here, and it's decreasing because it's going down from left to right. Notice here that they've included a break in the graph to help get all of the data on the graph really, really nicely. So that's helpful, and it's something that might help you if you're drawing a graph by hand, because we don't have to start at 0 and then have a bunch of empty space at the beginning of our graph. So it looks to me like at time 0, so basically when you take your hot sandwich, I guess, when it's initially prepared, when you've just made it, and it's at maybe a temperature of about 30 degrees, it looks like here. This is the beginning. And as time goes on, well, your hot sandwich decreases in temperature. And you might be thinking, well, why does this matter? Well, if you're a public health inspector and you're going around from restaurant to restaurant and you're taking the temperature of food to make sure that they're meeting health standards, right? There's a point where if you have meat where it's no longer safe for human consumption if it reaches a certain temperature and stays there for a certain amount of time. So that's an example of who might use this type of graph to make sure that the food being served in a restaurant is safe, right? So at the beginning, at time 0, it has a very high temperature. Maybe there's a point where that sandwich is no longer servable after a certain number of minutes, and then it has to be thrown out. So I'd like you to take a minute and take a look at this graph, pause the video, try to interpret what it means, what the meaning of this graph is, what that trend is trying to tell you. And then when you're done with that, what I'd like you to do is then listen to what I have to say about my interpretation, and then you can see whether you were in the right way of thinking about it. So I'm going to go ahead with my interpretation. I can see that it's a nonlinear trend, but there's still a trend going on there. So I'm going to look at the data labels to help me figure out what's going on, what this trend means. So it says average units of electricity used and peak temperature, right? So I'm starting out at 0 degrees Celsius, going all the way up to 40. And it looks to me like I use the least amount of energy, the fewest units of electricity, around 10 degrees Celsius. Around 10 units at around, it looks like about 18 degrees Celsius maybe here. And any temperature that's colder than 20 degrees Celsius, the amount of energy I use goes way up, and increasingly so. And outside of that 20 degrees Celsius, past that, once it gets hotter, I'm also using a whole lot more energy. If I had to explain why this trend makes sense, I would say that, okay, well, below, let's say 18 degrees Celsius, it probably starts to get a little chilly, and so I turn on the heat. And if I'm turning up the thermostat, I'm going to be using electricity. When I look outside of 20 degrees Celsius, the amount of electricity starts to go way up again, probably because I've had to turn on my air conditioning, and that's going to use quite a bit of energy. So if that explanation is not in line with what you were thinking, make sure that you clarify with me and I can go through it with you one-on-one. Okay, so here is an example. In this case, they're saying to me, plot what is the relationship between speed and stopping distance. So speed in kilometers per hour is, just if you're driving along in your vehicle and looking at the speedometer, seeing how fast you're going. Stopping distance describes the distance that your car will travel once you press on the brakes. Right, so even though you might be pressing hard on your brakes in your car, it may still take a while for your vehicle to come to a full stop. So in part A of the question here, it says develop a hypothesis about the relationship between speed and stopping distance. All right, so I know from my own experience that the faster I'm going, the harder it is to get my car stopped. So right? Because things that are in motion tend to want to keep moving. So my hypothesis is going to be that the greater the car's speed, the longer or greater the stopping distance. Okay, that's going to be my hypothesis. Let's see if I'm right. So the next part of the question asks me to create a scatter plot using this data to identify if there is indeed a trend. So I'm going to go ahead and do that on Google Sheets, and I'll show you the graph. All right, so here's the graph that I created using Google Sheets. And so when I look at this information, I can see that it starts at 0. So in other words, when the speed is 0, the stopping distance is 0 because I'm already stopped. But then it seems to curve sort of upward. Okay, so there's my scatter plot. Let's take a look at that scatter plot to try and answer the rest of the questions. How strong is the relationship between speed and stopping distance, and how do you know? All right, so pause the video and try to answer this for yourself. So checking your answer, I would say that this is quite a strong, in fact, it's almost a perfect correlation, but it doesn't look like it's linear because my data points are all sort of following a similar path, right? There's a curve that it seems to be following. So that lets me know that this is in fact a fairly strong correlation. So part D of this example asks me to create a trend line. So I'm just going to quickly move over to Google Sheets for a second here. Here's my graph. And I want to add a trend line. There are different ways that you can do that. I'm going to use this quick edit mode, which I didn't talk about in our last video. And when I do that, if I click on the data series, and you can see this sort of little arrow here, and you'll see trend line none. That's because I don't have a trend line. Now, if I were to input a linear trend line, it actually doesn't look that bad, but I think that because there's definitely a curve there, I'm going to see if exponential works. That actually doesn't look too great. I've got points above and below, but that curve doesn't really seem to be following the trend. So we're going to go polynomial and see it's a second, third, fourth, fifth. So I'm going to try second order, see if that fits. Ooh, that's a really good fit. Let's try third, just to give you a sense of what that looks like. Third order, oopsies. That's not too bad. I think I like second order. Fourth order, ooh, that's a little bit better, but it's kind of doing something wonky down here. You'll see if I put sixth order that, whoa, that goes really strange. All right, so I'm going to go back to second order because I feel pretty comfortable with that. But now I've included a trend line. So let's just go back to the question. All right, so the next part of this question asks me to predict the stopping distance from a speed of 120 kilometers per hour. And it asks if this is an example of interpolation or extrapolation. So I'm going to take a look at my graph and show you how I would figure this out. So I want to know at 120 kilometers per hour how long my stopping distance I would expect that to be. So I'm going to insert a little line here to show that. So 120 degrees is right here. So I would go right up to this point on the graph, right up to my trend line. And I'm going to use that trend line to fall over to my vertical axis. Fall right over. And so if I were to look at that, well, it looks like between 75 and 90, this is kind of a strange scale they've created. There's a difference here of 15. So that means that 75, halfway between 75 and 90 is going to be, there's going to be 7.5 meters difference, right? So 75 plus 7.5 puts me at 82.5 meters. So I would say that that's 82.5 meters is my stopping distance. And is this an example of interpolation or extrapolation? Well, I would say that it's already inside my line. I didn't have to extend this line further out. It's within the data that I've already collected. So this is example of interpolation. Because the information is inside the data. All right. So again, we've identified that this is a nonlinear trend, but that doesn't mean necessarily that there's no trend. Here we can clearly see there's a relationship between these two values. It's just not that they're not linear. All right, so now I'd like you to proceed with the assigned homework. If you have any questions, please feel free to ask me to help you one-on-one to explain any of the details that were in this video.